Or you talk.
अरे नहीं सर, वैसा नहीं होगा। अब मुझे यही देखना है कि स्क्रीन कैसे शेयर करूं।
सर शेयर इज
वो
नीचे सर स्टॉप
अच्छा,
वीडियो
शेयर
व्यू
शेयर एक आ
शेयर।
गया है।
यस सर।
ऑप्टिमाइज फॉर टेक्स्ट एंड इमेजेस, ऑप्टिमाइज फॉर मोशन एंड वीडियो। मोशन एंड वीडियो कर लेता हूँ। शेयर एंटायर स्क्रीन, बिल्ट इन डिस्प्ले, एंटायर स्क्रीन। अब एक गंदा सा स्क्रीन दिखना चाहिए। सर गंदा सा स्क्रीन दिख रहा है।
नॉट गंदा सर, बहुत अच्छा दिख रहा है।
अरे सर ठीक है, शुरुआत कर दूं सर।
Yes, sir. Just give me 1 minute. Let me introduce you, sir. It's my pleasure to introduce Professor Sumantra
ओके सर।
Dattare, who is currently working as a professor in the Department of Electrical Engineering at IIT Delhi. So, Professor Sumantra has obtained his PhD and master degree from IIT Delhi, and his main research area or interests are pattern recognition, machine learning, biometrics, computer vision, image processing, and he has received several awards, including the Boyscast Fellowship for the year 2004 and 2005 from Department of Computer Science and Engineering. So he was also awarded the INE Young Engineer Award for the year 2003. And he has published several papers. He is also serving as an associate editor for the prestigious pattern recognition letter journal. So with this short introduction, sir, I request you to please start the session. Thank you.
सर बहुत धन्यवाद सर, थैंक यू वेरी
Thank
मच
you.
for the kind invitation, and in the list of participants I can also see some familiar names. Well,
Yes.
if these names, if my name is familiar to you and if you have heard this particularly unstructured talk before, please forgive me, because the material will be almost exactly the same, the mistakes will be exactly the same, and so so the horrible presentation will be exactly the same. All right. I'll actually start off in a completely unstructured manner. So, Nayak sir, the problem would have also arisen because I use an incredibly old laptop and it's very slow. It's got a small screen, and I hope something will work, because the moment I make a full screen, I'll not be able to see anything. So if any participant has to say something, please allow them to unmute the microphones, because I won't be able to see the chat box. It's a tiny screen, sir.
I mean, we have requested all the participants to interact with you at the end of the lecture, sir, and the end of the session. No problem, sir. You can just start,
Okay,
sir.
sir. Okay, sir. So I'll
Yes.
actually start with, this is actually not a very structured way that computer vision has proceeded in the millennium. And as you can see, most of this lecture was made for a presentation which was in the heat of the pandemic period, June 2021, and now it's nearly 25 years into the millennium. So it's not a uniform sampling. I'll try to cover some things which at least would sound interesting to a person who's interested in computer vision. The first development actually started in the late 1990s. This is single view metrology. And let's go into it directly with the help of a couple of videos. A couple of videos and a couple of projects. I'll talk in the background. So these are a couple of, so this is Antonio Cremonesi's work. And one of the things that he did was he literally brought paintings to life. I'll come to this. So let's look at this. So this is the Merton College at Oxford, and if you're able to see this video, one of the interesting things would be that this entire video, the entire VR model, in fact, has been made from one single image. So there are a couple of interesting things here. A question that should come to everybody's mind is that, is it possible to do so automatically? How much is it possible to do automatically? So all of the information here in this VR model has actually come from one single image. And some of the assumptions you can well see. Some of the assumptions are that there is a planar world assumption. The assumption is that most things in the world are planar, and what we are trying to render realistically is objects which have lots of planar parts. So let's look at this shared example. Well, this is Antonio Cremonesi himself in this video. So once again here, this video has been made from one single image. This is single view metrology. And as you can see in this VR model, Antonio Cremonesi appears like a paper cutout because there is no other depth information. On the other hand, with a couple of examples, that is, most of the world is planar, and plus there is typically there is a perspective point in perspective projection, because if I write out the perspective projection equation, it is essentially a depth scaling. So the x and y coordinates are essentially scaled by the depth. This is in fact one of the core tenets of computer vision. That is, I can write, this is in fact, this comes from a pinhole camera model. I can write small x, which is the distance in pixels along the image, divided by the focal length. I can write that as a ratio of capital X, which is the distance in the world, divided by capital Z. And in fact, this simple equation tells us why railway lines appear to meet if I stand on if I stand between two railway lines and look into the distance, hopefully without a train coming in towards me. Okay, then I'll lose my sense of perspective a little bit. All right. So here, one of the things that you can see is that this essentially tries to recreate a planar world from one image. And you can see that some of the parts which were not visible in the original photograph. Okay, so Antonio Cremonesi appears as a planar cutout. And in fact, the other side of the barn, that because that was not visible in the original single photograph, no details of that come in. That part is understandable. I think we know this. But the key point is that this is also this is also Antonio Cremonesi's work is also something which was actually quite intuitive, which is quite intuitive for every human being. For instance, when a person enters a room, how do we approximately get an idea about his or her height? We know that, for instance, the standard size of a doorway is 7 feet. So if a person enters in, we can automatically, using similar triangles, because what we have, see, what allows us to make this estimate or make this reconstruction is the fact that we as human beings already know the measurement of certain things standard. For instance, if I look at curtains in a room, that helps us to estimate heights. Once again, why? Because if I have a standard half length curtain, that is 4.5 feet, and a standard full length curtain is 7 feet. So if a person stands beside either a standard half length curtain or a standard full length curtain, we have a fair idea of his or her height. Now, the thing is, even if we are not able to make actual measurements of the height, because a measurement need not be there as a reference. For instance, a standard length doorway, it need not be there. But the important part is we may not be able to make a Euclidean reconstruction. Euclidean is in the full Euclidean space. However, we may be able to make a metric reconstruction. This is important because in a metric reconstruction, what we are doing is we are essentially looking at not a Euclidean transform, but we are looking at a similarity transform. So we are looking at scaled lengths. So even that is possible. Now, why am I mentioning all this? I'm mentioning all this because this was one of the first things which Cremonesi had showed that time. Look at this. So this is a painting, and literally, so this is the famous painting, The Flagellation of Christ. So here he is able to make a 3D reconstruction from the painting. Why is he able to make the reconstruction from the painting? See, all of these figures, because there is no other way of finding 3D information, these actually appear as paper cutouts. However, the information about the vanishing point is there. The information about perspective projection is there. It is there in the tessellation of the floor tiles. It is there on the pattern on the ceiling. It is there inside the corridor. This information is actually there everywhere. Now, if one makes assumptions such as the height of this column is 10 feet, then it is possible to make these reconstructions and appropriately create a virtual reality model. The important part is all of this information comes from one image. Now, there is something quite fascinating. Like ancient Indian paintings are also supposed to be a work of art. However, one of the interesting parts is that if, for instance, one looks at the Rajput paintings or the Mughal era paintings, you'll see some problem. What is that problem? There, in fact, there are paintings wherein every hair in Jahangir's beard, there's that famous painting of Jahangir holding a rose. So, if, or was that Shah Jahan? I forgot, and I think it was Jahangir. So, every beard, every piece of hair in his beard was rendered using one hair of a squirrel. So, this is the interesting part. There, it is there in finesse. However, if, for instance, if you look at the 16th century painting of Akbar's half brother being thrown down from the ramparts of the Agra fort. So he was Adam Khan. He was the son of Akbar's wet nurse Mahamanga. And in fact, Adam Khan's tomb is in Delhi. It's in Mehrauli, if you've seen that. So if you look at it, there's a problem there. The world of the painter is affine. So you'll see parallel lines being rendered parallelly. There was no concept of perspective. Perspective actually started in Europe with the paintings of the Renaissance era, wherein Renaissance masters, it started with Botticelli. Botticelli had possibly the first perspectively correctly rendered painting. And if we actually look at those paintings, it is possible to get 3D reconstruction. Now, I was talking about some assumptions being made on the world. So let's look at La Trinita. So if let's look at La Trinita and we assume square coffers. So this is the La Trinita. So this is Christ on the cross. These figures will appear as cutouts. But so what are our assumptions? Our assumptions are essentially that the base here, okay, this base is rectangular. Okay, we have assumed that this base is rectangular and we are assuming certain dimensions. So from the La Trinita painting, it is possible to get this 3D model. It is possible to get this 3D reconstruction. So the idea is this is single view metrology. Okay. Now, if we make a different assumption, let's say we assume a square base. So if we assume the base to be square, the reconstruction will be accordingly. Now look carefully when we come to the base. Now in this case, look carefully, we have assumed that the base is square. So if the base is square, then according to our assumption, we have a different reconstruction. Fine. Once again, 3D objects will not be rendered in 3D like human beings. They'll only be cardboard cutouts. Similarly, all surfaces will end up being cardboard cutouts. However, the information which is there in terms of the depth, that allows us to create a complete 3D model from one painting, depending on our assumptions. So this is another famous painting, Saint Jerome in his study. So here you can see the portions wherein the information is not there. It is not there. It is just drawn in black. like what is behind this window or what is inside here. But the most fascinating part is everything else is assumed to be planar, and planes are rendered perfectly in the 3D world. So who started? So when did the concept of, okay, there's, I have another famous painting here. This is by Vermeer. Vermeer was a famous Dutch painter who was known for his intricate knowledge of perspective. So if you look at this very carefully, this lady is playing the piano, and there is this one person who, in a ghostly manner, he's just standing in space because that was occluded by some object. Now, the details of the piano were not there in the original painting. So there is no reconstruction here. This part has been drawn with black. But then look at the perspective. So all of this rendering, getting this not perfectly Euclidean, but a metric reconstruction, it is perfectly possible because of the tiling, because of the perspective, which is already there. The windows, the lines here meet at a point. Okay, so that itself contains enough information in order to have at least a metric reconstruction, that is a scaled perspective projection, if not a complete perspective projection. Now, how is this interesting to us? And one very practical example of this actually happened in 2019 on the 27th of February. I've forgotten the date. It was sometime in February, wherein Wing Commander Abhinandan Vartaman of the Indian Air Force, piloting a 1960s era MiG-21 aircraft, was the first in the world to shoot down a Pakistani F-16. Now, obviously, we have seen something like this. We have seen the denials even after Operation Sindoor, and our Chief of the Air Force AP Singh, he gave his estimates only after we were dead sure that 6 aircraft of the Pakistani Air Force had been downed in no time at all in those 20 minutes of warfare. Now, what happened in 2019 was that this was over Pakistan occupied Kashmir. So there was a dogfight, and our wing commander Abhinandan Vartaman had done something which nobody else in the world had done before. Using a 1960s technology MiG-21, he had downed a F-16. Now, obviously, Pakistan denied it, left, right, and center. The interesting part was, if you look up squadron leader Zoshi's blog, what he's done is he has actually used single view metrology to actually give proof. The proof is there in the public domain. Now I'll motivate this because, so this is squadron leader retired Samir Zoshi, his articles. I've given some links also to these, like this appeared in the print also. 8 pieces of clinching evidence that show how IAF's Abhinandan shot down a Pakistani F-16. Now, the interesting part is, because of the prevalence of social media nowadays, so people had actually recorded some very crucial pieces of evidence and put them in the public domain from their mobile phones. The advantage of mobile phones is that the video is geo-tagged. Images are geo-tagged. The latitude, the longitude, the height, if all of this information from, and of course the GPS information is there. That information is already there. Now, if we combine them with things like Google Earth, so unlike Google Maps, which is a 2D representation, Google Earth has a 3D representation. So if from the video one does a point to point matching with the model of the terrain. Most of the world is mapped using Google Earth. So if one does a point by point matching, one can actually get 3D information. And the key here is single view metrology. Even single view metrology has helped in this case. Let us go frame by frame. There were 3 videos which were taken that time, 2 from Pakistan occupied Kashmir. So one was a video filmed by, this was a dogfight where both the aircraft were visible. So the Pakistani F-16 as well as Wing Commander Abhinandan Vartaman in his MiG-21. So there was one video which was taken from Charhoi in Pakistan occupied Kashmir. There was one video which was taken from Thana Mandi in Jammu and Kashmir, and another video which was taken from Koirata in Pakistan occupied Kashmir. So let's see the videos. And this was all over the news channels. Okay, so what you can see here, this is poor resolution, but then you'll clearly see 2 tracks of the 2 aircraft who are circling each other at incredible speed. And then incidentally enough, both of them come down. So in fact, Wing Commander Abhinandan Vartaman had a window of 54 seconds. He knew that he was going to be hit. But within that window of 54 seconds, he fired a missile and downed the Pakistani F-16, which nobody in the world had done till that date. So here, because what is the advantage of a video? So there is a proper trail, condensation trail for the altitude at which these aircraft were. The video was geotagged, and there are some other interesting frames in this video. Plus, the advantage of a video is that the chronological information is there. That is, what is after what. Now look very carefully. In this video, I've paused it here. The complete terrain is visible, including a microwave tower in Pakistan occupied Kashmir. There is the terrain here. There are houses. This information is there. That is, in this season, there is a hillock here. There are some houses here. So it is perfectly possible to actually, and then finally, look, the Pakistani Rangers, the helicopter here. So the Pakistani Air Force F-16, after it went down, the Pakistani Rangers, they sent a helicopter to the crash site. It is all there in the public domain. And in fact, because the aircraft fell inside Pakistan occupied Kashmir, so we do not have proof of the debris. But then this is evidence fair enough. So I'll come to a couple of other things wherein, look, the position of the sun in the sky. What are the pieces of evidence? The terrain. So this is an unstabilized video, but it was even the house on top of which the person taking the video was located. It is possible to do 2D triangulation. It is possible to do 3D triangulation. It is possible to get other information from the position of the sun, because shadows at that particular point in time, the position of the sun across the sky was documented. So a shadow essentially is from the source of light to the ground, and it is just similar triangles. That's all. It is similar triangles. The moment we have correlated points, let's say here, the hillock, with what we have in our Google Earth model, or let's say the microwave tower there, the moment we have that, we have actual heights. So if we have actual heights, we also have actual lengths. And well, the very simple way, what is the main way in which we human beings perceive depth? We human beings perceive depth because we have the left camera in the left eye, we have the right camera in the right eye. Now, for any 3D point, we have its image in the left camera, we have its image in the right camera. Our brain establishes a correspondence between the two, giving us the ground truth that this pixel in the left image corresponds to this pixel in the right image. So how do we human beings perceive depth? The main way is from the left image, we essentially draw a 3D line to the optical center of the left camera. For the right image, we take the pixel, we draw a line in 3D to the optical center of the right camera. We extend that into space wherever the two meet. See, in 3D, two lines will either meet or they will not meet. If they meet, that is triangulation. Our brain does that very fast. If they don't meet, there could be two cases. One is they are either parallel or they are non-parallel, non-intersecting. Now it turns out that if I actually have a correspondence and there's a good overlap in the field of view, then it is possible to do that triangulation. Okay, so I'll let the video run. So this is the video from Charhoi, wherein the Pakistani Rangers helicopter is going towards the actual F-16 crash site in Pakistan occupied Kashmir. This is the first video. The second video has been taken from Thana Mandi. Thana Mandi is in Jammu and Kashmir. So you can hear them talking in Urdu and Kashmiri. So the advantage of the video is that temporal information is there. There are two trails, and then finally both trails of both the aircraft going towards the ground. So this is again interesting because this is in Pakistan occupied Kashmir, where we have no idea of the ground truth, but Google Earth has a model. Google Earth has a model, and if we can make some allowance for the fact that in different seasons the vegetation may be slightly different, but some man-made structures would not change. Look carefully. So it is because of these things that people were actually able to register a video down to the roof of the house where the person was actually standing, because there's a huge lot of background here in addition to the two small specks in the sky, plus the fact that there is temporal information in this video. So look at it as how it comes, and of course there is the language, the fact that one aircraft has been downed and the second aircraft also. So they're talking about two parachutes. And in fact, unfortunately, the Pakistan Air Force pilot was lynched. He had fallen inside Pakistan occupied Kashmir, and the villagers thought that. So you can see the parachute here. So in fact, he was lynched the moment he came down, because the parachute which was issued apparently by the Pakistan Ordnance Factory was in fact in three colors. Okay, they thought that it was an Indian one, and they unfortunately lynched the pilot. On the other hand, Wing Commander Abhinandan Vartaman, he, with some real extreme heroics, he survived, and he also came back, and in fact, the then video chief, the Air Force chief who retired, he had taken his last flight with Wing Commander Abhinandan Vartaman, that too, both of them in MiG-21s from. This was all pretty fascinating. They did it from either the Adampur Air Base or the Pathankot Air Base. Okay, it's fascinating. Now let's look at these pieces of evidence. So the first evidence is 27th February 2019. In the 10-minute period, what is the position of the sun? See, this information is available in the public domain. That is, the sun across the sky went like this. So this is Pakistan occupied Kashmir. This is the Mangala Reservoir. This is the position of the sun. So we exactly can correlate with the source of light and shadows, because shadows give us one of the best sources to do 3D metrology using 2D information. Okay, so all the single view metrology comes from these auxiliary sources of information. Now, to the extent that the observer at these 3 points, at Thana Mandi in Jammu and Kashmir, then Charhoi and Khuirata in the last two in Pakistan occupied Kashmir. So people were able to, so squadron leader Samir Joshi, he used all of this to triangulate and find exactly which house was that the person who took the video, where he was standing on in Pakistan occupied Kashmir. So Charhoi is here and Thana Mandi is here, somewhere here, and Khuirata is here. So within that period, it was possible to do everything. So with geotagging, so look here, this is the Thana Mandi video, and because Thana Mandi is in our country, it is possible to get some more information, but squadron leader Samir Joshi, he just did it from the video. So look, this is point correspondence between the Google Earth model and the frame from the video. And using that, he was able to point out where the observer was, which direction the observer was looking, which is the direction of the sunlight, everything. These are some of the information. So all of this, in fact, has come from, so squadron leader retired Samir Joshi. He's also picked up information from other users on social media. I've put the ID of some of these users who had put this information in. So on Twitter, these were the people who have put in all of this information, and all this is in the public domain. That's fascinating. Then this is the geotagged aerial battle over Pakistan occupied Kashmir, because Wing Commander Abhinandan Vartaman had crossed the border. So these are the two aircraft. Okay. And as observed by the observer at Charhoi. See, remember, one of the important pieces of evidence, what I told you, was the microwave tower. The microwave tower, we have a more accurate description of the height. What is the second piece of evidence that I told you about? The position of the sun. In the video, as well as what we know from the ground truth of the sun moving across the sky in those 10 minutes of time between 10:20 a.m. and 10:30 a.m. So you can see here the observer located on this building, okay, on a small house. It was possible to exactly pinpoint both the latitude, longitude, the height, as well as the angle at which he was holding the phone. Isn't this fascinating? So in taking the match, let's look at two views. This is one of them. This is a match with Google Earth. So this is that point. So this is where that Pakistan Ranger helicopter is. This is the original video from Charhoi in Pakistan occupied Kashmir. So this was used to essentially get the correspondence. And remember, correspondence is our main cue of depth. And this is for the second view. So this was really fascinating, even if one made some allowance for the vegetation changing slightly. Okay, it is perfectly possible to get Euclidean or even scaled Euclidean information, in this case perfectly Euclidean information, because of things known like heights, like altitudes, everything being known, the position of the sun, everything being known. So these are the three positions. This is at Charhoi in Pakistan occupied Kashmir. You can see this. This is at Khuirata, and every incident from the video was put with temporal coordinates. It was superimposed, and this is the line from Khuirata to Thana Mandi. Thana Mandi is in Jammu and Kashmir. This is the LOC. Okay, and this is the exact point where what Wing Commander Abhinandan Vartaman had fired was an R-73 missile which had hit the Pakistani F-16. So he's fired it. All this information is there frame by frame. And this is the trajectory of the missile, which has changed trajectory now to hit the F-16. Okay, and he had about 54 seconds before he knew that he would also be hit and both planes would come down, but he didn't hesitate. So the Quirata video, these were the, so as you can see here from the video, one of the things that these people on social media have done, they have also reconstructed a mosaic. Okay, from the video they've constructed an image which has the same resolution as each of the video frames but has a wider field of view. So they reconstructed everything, including which side what went from where and at what point in time. So the Quirata video was sort of flattened out here and the two planes. Okay, so this is in fact from the video at Quirata. So there's a puff, a parachute, there's debris. So this is Wing Commander Abhinandan Vartaman ejecting from his MiG-21, but he had already shot down the Pakistani pilot because there's a second puff which is visible. There's a second piece of debris. There's a second parachute. And in fact, if you remember, Imran Khan was that time the Prime Minister of Pakistan. He had talked about a दूसरा बंदा, एक दूसरे बंदे को भी हमने पकड़ा है. That दूसरा बंदा actually turned out to be the Pakistani air pilot who unfortunately lost his life because the villagers lynched him, thinking him to be an Indian Air Force pilot. Fascinating enough? Let's see something more. So at Quirata, so getting the correspondence. So this is flat Google Earth or Google Maps. This is the terrain information which is coming from the video. So painstakingly people did manual correspondence. Okay, hills, valleys, points, man-made features are slightly better. This is the Quirata correspondence number 2 by user Bishwa. So buildings here, the way that the video went, the way that the person turned his arm, this is the crash of Wing Commander Abhinandan's aircraft after he ejected using a parachute. So this is the falling debris. So the MiG-21 crash is recorded along with the proper triangulation. At what height was Wing Commander Abhinandan Vartaman hit? When did he, at what point in time and space did he actually eject from there? And look at this, all of this is triangulation. And a similar analysis is there for the Dusra Banda and the second aircraft. So this is really fascinating. If you ever get the time, please look up Wing Commander Samir Joshi, retired, his article. There's an article in the print also. So you can check that out. All right. Now, coming to some other developments. So see, most of the developments in computer vision are due to deep learning. In fact, it's actually the other way around. Deep neural networks actually started from 2D images. And Jan LeCun was actually working on 2D images. So that is why most of the standard neural network models are actually for two-dimensional entities. So quite a lot of developments in computer vision happened due to deep learning. I'll try not to cover those, okay, because you'd know most of them. And Deepak Nayak sir is an expert, and I can certify because I've sat in his lecture. He describes these beautifully. So I'll try to describe some of the things which do not involve a lot of machine learning or a lot of deep learning, but are millennial developments. One of them was this project of what they called building Rome in a day. So before I show you the videos, let me see if I can. So this is from the Department of Computer Science at the University of Washington. Now, Let me get the entire thing up, and then I'll start the descriptions. Okay. So there's something interesting. At tourist sites, nowadays with social media, people upload millions of photos on the web. But one might say that they are completely arbitrary. The actual point here is they are not. Because let's look at a typical popular tourist site, let's say the Taj Mahal. So there are, in fact, people do not take and post arbitrary views of the Taj Mahal. So typically there is that one view from the doorway when you enter. Then there is a view from the fountains where apparently Princess Diana had sat. Then Vladimir Putin had also sat with his wife. That so there are pictures from there. Then when one comes to the platform, the plinth, there's one which is looking up. So the point is, the views which people upload from on the social media, they are not completely at random. And if they are not completely random, then even if we apply a brute force technique, it could be a very simple correspondence based calculation. It could be take a simple correlation in a small window around a point of interest. So run a 2D corner detector. So this process itself, the image processing, is very noisy. But the thing is, if we have the compute power, it is possible to look at arbitrary images and from those millions of photo do a perfect 3D reconstruction. That is the thing. But the challenge that time, so this is in the early 2000s, was to do this matching and create the 3D structure in a day. Okay, 24 hours time. So Rome was not built in a day, but the 3D model for Rome would be built in less than 24 hours of compute time. That was the challenge. Then, in fact, so this is Steve Sides. This is the work of Steve Sides. He had a position in the University of Washington. His wife, by the way, is an Indian. So, so there's something fascinating there. Let's look at some of those reconstructions. So this is the Colosseum at Rome. So what you can see here are the points for which a perfect reconstruction was possible. They've also been colored. Okay, so this is the Colosseum. Now, what are these little dots out here, which when blown up result in this triangular structures? These are effectively pinhole cameras. So what was done was, for arbitrary tourist photographs, people did this reconstruction, a stereo matching and reconstruction. They were able to recreate the position of the camera and do a perfect 3D reconstruction. So this is the Colosseum. This is the Trevi Fountain. So all of these are the reconstructions of where the tourist would have taken a photograph from. The other advantage of having mobile phone cameras is that the geolocation, these things are geotagged also. So that information also helps. Okay. Along with the current focal length, the current estimate of the focal length that is there, for instance, in the EXIF information, the EXIF information which is there in a JPEG file, for instance. So this is St. Peter's Basilica. So look at the quality of this reconstruction. And all of this was using the hardware that we had some 25 years back. Okay, so no GPUs. So this is the canal. This is the Rialto. This is the Rialto bridge over the canal. All of these. So every point which was reconstructed has also been interfaced with the color of what that pixel was in the original video. All this is 1990s not 1990s, the millennial development, the 2000s. So this is San Marco Square. Okay, so this is the cathedral with these domes. All right, and you can see, look at the number of cameras which have been reconstructed. This also goes on to say that, so this is that famous spire. This also goes on to say that the photographs that people take in places of interest, they're not taken from arbitrary viewpoints. Look at the reconstruction of the camera. Do you think they are arbitrary? No, they are not. Okay, this is fascinating. Then this is the old town of Dubrovnik in the Czech Republic. One of the characteristics of the old town of Dubrovnik is the presence of these geometric structures. This is that old clock there, and this is a reconstruction from there. So each point is colored with the corresponding color it had in one of the images of that pixel which was uploaded on the internet. So this is a reconstruction, and this looks fascinating. And in fact, the trend that time was to build Rome in a day. Okay. Then the cloud had come in. So that brought down the time a little bit because storage would also be an issue. So their next paper was building Rome on a cloudy day. Okay. So effectively, they're using information which they have already put on the cloud. And then the last part of their algorithm was building Rome on a cloudless day. What happens if you don't put it on the cloud? So you need a proper data structure. You need a proper data structure at different levels of resolution. Okay. Now, some of the other work. So once again, Steve Seitz's work, then I'll come to some of my more famous colleagues. I'll come to some of their work also. Once again, with a large number of photos on the web, it is possible to create a time lapse or a virtual time-space moving camera. And the more fascinating part is the depth varies with time, point colors, and the reconstruction should not have any holes. Look at this. So this is Lombard Street in San Francisco. So this is in fact said to be the most crooked street of all. So even if one hasn't been there, one may have seen it. So this appeared in ICCV 2015. So look at this. So this is the most crooked street in the world. Okay, so it goes like this. Now, look at this. So this is a time-lapse photography across seasons of things which have been matched. Previous work assumes a static camera. Now these people will assume a dynamic camera. All right, and make these reconstructions. So this was the previous static camera. This is with a dynamic camera. More information, but then many more assumptions. Then Steve Seitz highlighted their approach of first finding a time varying depth map. See, the camera is moving, it's not static. Then what it does, it maps them onto this contour and does a regularization of color profiles of a particular point across time, because see, this needs to be done across seasons. All right. And some other interesting results. This is in fact the Bayou temple in Siem Reap, Cambodia, Cambodge. Okay, because at that particular point in time, let's not forget that the entire Southeast Asia was under the control of the Cholas. Rajaraja Chola and his son Rajendra Chola. In fact, one of the Chola rulers traced his genealogy to Vietnam. So in fact, most of the names of, so this is one building in New York City. So in fact, most of the names of countries and places in Southeast Asia, Sri Vijaya, that is one of the names of places. Then If you looked at names of people, in the Philippines, Indonesia, you had Meghavati Sukarno Putri. She was the leader of Indonesia. So Meghavati, she wrote Megawati. That's Meghavati, the daughter of the clouds, and the daughter of the more famous politician Sukarno. And in fact, they have the Ramayana and the Mahabharata also, they play it there. Whereas there's almost no population which might indicate that there's some effect of religion. It is all done from the times of the Cholas, Rajaraja Chola, Rajendra Chola. If you look at the names of the countries, Brahma became Burma, then Saumitra became Sumatra, Jambu Dweepa became Java, Siam became Siam in Thailand. Then if you look at the prime river which flows through Thailand, that's called Irrawaddy. What is that? That is Irravati. In fact, one of the 5 rivers of the Punjab is also named Irravati. What is called today, the Sanskrit name is Irravati, but currently today it's called Ravi. It's not called Ravi, it's Ravi. Ravi comes from Irravati. So all of these are actual consequences of the fact that Indian power that time through Rajaraja Chola and Rajendra Chola, it's actually been there for many, many years. Okay, so these are coming back to this, these are reconstructions across time and assuming a dynamic camera which is moving, so it is not even static. This is the Arch of Constantine in Rome across different seasons. Okay, with different assumptions, with different qualities of reconstruction. It could be a non-geometric pattern, like forget buildings. Buildings are easy. This is a glacier, mountains. So to do that, it's not very easy. Let me quickly jump through a couple of these. This is a waterfall. Then this is that famous Wall Street bull. So depth map optimization, how to remove holes. This is the initialization. Then I'll show you something close to home also. Some of my colleagues' work. So large scale 3D reconstruction or structures from motion. Well, this is again on the Rome data set, but this is some of the work of Professor Shubhashish Banerjee at IIT Delhi. So he made a data structure, and it was actually a multi-resolution tree. So to store information at different levels of resolution and to combine pieces of information which actually matched across views. So he did that for the Rome data set. So he's showing some of the constraints which he's used here. Then refinement with batch processing. So getting better and more consistent information. So it also depends on the data structure one uses. It's not simply a brute force. So this is Rome. Let me see if I can get something more familiar. So this is all for, this is the Vijaya Vittala temple. So this is the stone chariot, the world famous stone chariot. It's here. This is the Vijaya Vittala temple. The reconstruction of that. This is the art squad again at Rome. Piccadilly in the UK is reconstructed that. St. Peter's Basilica, this is in Rome again. So he loves traveling. And no, that thank you is not from my side. I'll bore you for a couple of minutes more. I know I've already crossed 1 hour, but I'll show some things interesting. So he uses structure of consistent structure motion with graph partitioning. So here these are reconstruction of individual components taken from different cameras, different viewpoints. And what he's doing is he's projecting them onto the same Euclidean coordinate system. So he registers with the help of epipolar geometry. What is epipolar geometry? Epipolar geometry says that if I've got a point, so in order to search for its correspondence in the other image of a stereo set, see, if I have a pixel in the left camera image, if I want to search for the corresponding pixel in the right camera, is constrained to lie along a line. I should not have to search anywhere. So this is the epipolar constraint. So with epipolar registration, so for instance, this is St. Peter's Basilica. This is central Rome. You've seen many of us have seen the Vijay Vithala temple, right? It's a World Heritage Site. The stone chariot. Okay, this is something that I've already shown you. Then this is the work of another of my colleagues, Professor Chetan Arora. So something's fascinating, that is stabilization. Stabilization not of a single camera video, this is stabilization of a 360-degree camera video. So look at this. So you know that YouTube, if you upload a video onto YouTube, YouTube does an auto stabilization. Okay, it uses some very nice heuristics. The author of that paper, this is, I believe, a CVPR 2011 paper. Vivek Quatra is the author of that. Vivek Quatra is also a IIT Delhi alumnus. Our Chetan is also an IIT Delhi alumnus who's come back now as a faculty member. And this is a stabilized 360-degree video. So this is Chetan walking through a highly cluttered computer lab. The first is an unstabilized one. Second is stabilized. So what he's essentially doing is he's looking at pixel traces which are across here and he's stabilizing them. Then this is the original of a person walking, okay, and jogging in fact, and this is the stabilized video. All right, then here this is another one. So this is a field of vision which is called egocentric vision, and our Chetan Arora is one of the best known researchers in this area. Then this is again at a hill station with a camera which is actually fitted to the helmet. And this is the stabilized. So this is dirt biking, quite a high speed and stabilization. So the original features and their traces are overlaid here. This is the stabilized video. So you can see how stabilized this is. And these are 360-degree videos. That is, videos which have also been stitched in real time. These are panoramic cameras. This is scary. This is one of those looping the loop things. So this is the near field of view. This is the original unstabilized. This is Professor Chetan's algorithm. This is very difficult to handle, remember. How will you do point correspondence here? There are no geometric features at all. It's very difficult. Then this is monocular slam. So this is Chetan, I believe, driving very, very dangerously all across the IIT Delhi campus. Okay, he's taking a turn close to the nursery and slowing down. Why? Because the security guard is there. Then he's speeding up once again and driving around at gay abandon in his car. This is the structure from motion, which he's, so the depth for the points where he's been able to reconstruct the depth, he's also coloring that point. The rest are all in blue, what he's not able to do. So after that frantic drive through the IIT Delhi campus, oh, I won't have much time for I won't have much time for anything else. But then, well, if there are any, I've put up whatever is here. Maybe I'll show just one of the videos. So deep fake started. I promise not to mention much in.
7 years ago, our ancestors dreamed that we would build our family tree and make fascinating discoveries about our family history.
This is a deep fake.
Heritage.com to embark on my journey.
So this is an advertisement for myheritage.com. And in fact, so these started with generative adversarial networks. GANs came about as a NeurIPS paper in 2014. And deepfake started with that. That is, learning a distribution so well that it should be possible to generate a new sample from that. So myheritage.com, if you download the free version of the Android app, and this is not today, this is many years ago, it is possible to generate a realistic looking deepfake in 20 seconds flat. All right. So here, for instance, Lincoln is talking about myheritage.com.
Names into my family tree. My heritage found riches of information about my ancestors, family trees, and records galore. I colorized and sharpened old family photos and can now see them in a whole new light. My heritage even connected me with new cousins around the world, like Dave and his wife Susie. Congrats, dear boy. Column A. Start today on myheritage.com and bring your family history to life. Making a lasting legacy of your family, by your family, for
myheritage.com.
How did I do? Be honest.
Okay, I guess I'll stop at this this point in time. Now, what I'll request Nayak sir is, I'm actually unable to see all of these. I'm unable to see all of these things in the chat box. I don't know why. Maybe because I'm using a very old computer with a very limited. It's in fact a bad advertisement for computer vision. And now I can't even see the chat box.
Yeah, sir. I can
Okay.
just summarize the questions. Yeah, you can. I think it is visible, sir. Now.
This is it. Okay. The
Yeah.
audio, Dr. Praveen, audio is not clear for
Oh,
me.
sir, this is an older one.
Okay. These were Pakistani Air Force F-16s. Could the hologram concept in deep learning be used to construct 3D image? See, the hologram, as I understand, it's a 3D image. Okay, a hologram is actually a 3D image. The point is, in computer vision, we need not create an actual 3D image. That's the idea. Okay, and if you're wondering about hallucination, that is different. Hallucination in large language models, transformers, that is slightly different. Okay, Dr. Thakur, thank you. What is the purpose of data structures? Okay, see, the data structures is how we represent something. Everything need not be represented at the finest level of resolution. So the idea is, if let's say the virtual reality model needs to zoom in, then we will go through that data structure. We will actually make a path through that data structure at the level of resolution which is required. So if needed, we can zoom in. So this is where and in fact, this is also called bundle adjustment. That is, put constraints left, right, and center. A set of it will be a large set of equations. Okay, maybe linearize them in some way, and then essentially try to work out a least square solution. So these take time, and especially on the kind of hardware that we are talking about. These are not GPUs. This is entirely in the pre-GPU era. Okay. For stabilization, reconstruction concept is used. This is actually very interesting. Dr. Shweta, this is a very nice question, because stabilization can be done without reconstruction. So if you or I were to upload a video onto YouTube, We won't do any reconstruction for that. The automatic YouTube stabilization algorithm of Vivek Quatra and his two other co-workers, see, they actually, some of these ideas are fascinating. So what they're looking at is continuity. They're looking at continuity of position. They're looking at continuity of velocity. They're looking at continuity of acceleration. In fact, some of the incentives, if you read that paper is reasonably understandable. It's not that tough. It took me a little while to understand because I'm not that smart a person, but the very basic ideas actually come from the way what they want to model is, typically a video has been taken with a non-stabilized camera and there is no calibration. All right, so we are not doing any reconstruction whatsoever. The idea is to assume that if the video camera were put on a film making, they call it a crab dolly, the the structure which moves around on rails wherever a film is shot. So they make their assumptions and they make their mapping. It's actually a fascinating paper to read, and it has the richness and the excitement of starting from scratch. All right, it's just a wild idea, mapping that onto things which traditional videographers use. Okay, so this is it, Dr. Shweta. Dr. Bora, thank you very much. Oh, so is this Dr. Rahul Sharma from LMN IIT at Jaipur? Thank you very much. Wonderful. Namaste. And
Yeah.
in fact, I see one of your senior colleagues from LNM IIT also on the participants list, Dr. Bansal, Dr. Anukriti Bansal. Fascinating. So I just hope, there Dr. Anukriti is. Good evening, Anukriti. So it's actually very nice to see familiar people also. Nayak sir, maaf kijiye. I've actually overrun. Not just did I start late, but
Yeah.
being a teacher, it's very hard to keep a teacher's mouth closed, even when one's spouse is nearby. I hear that it's not a gender specific thing. Some of our lady colleagues say the same when they are teaching and their husband is around. So we teachers have this unique thing. मुंह बंद करना बड़ा मुश्किल होता है. मुंह बंद
Yeah.
करना या कराना. So please forgive me, and
No problem.
I hope that you enjoyed it as much as I did, because
Yes, sir,
I've
absolutely.
been I've opened this slide deck. It's weird because I first made this in 2021. I added things here and there. I did not show you things which are chronologically together, but somehow, just as it said, kahin ka eat kahin ka roda, Bhanumati ne kunba joda. It's a little bit like that, but that's what I tried. I hope you enjoyed it, and I also enjoyed reliving some of my memories when I was preparing the slides. Kahan se loon, kya bataun, which would be interesting, which would actually not have too much of deep learning also. So I also wanted to select those 2000s concepts which would preferably not involve deep learning. Of course, I showed you deep fakes, but apart from that, the rest of it is actually pure geometry computer vision.
Yes,
Okay,
sir,
that is some
absolutely.
of the
Thank
things
you.
which actually binds a lot of us together, and especially some of the people who I know.
Yeah. So thank you so much, sir, for your wonderful talk, for sharing, lot of important informations. It's a kind of motivation, I think, to all the participants that where you can use computer vision, right? So sir has shown lot of such applications. I mean, each and every video, there are some interesting things which even I have been observing. So thank you so much, sir, once again for joining us, for sparing your valuable time with us. Thank you, sir. Thank you so much. I hope
Thank you, sir.
our participants have enjoyed.
And I'd request the participants to actually look up Squadron Leader Samir Joshi's articles. If you type this on the internet, you'll actually get a lot of information. And when you map it, it's actually single view metrology. All right. There's
Yes.
it's all this information is there in the public domain, and it's hardcore proof that what Wing Commander Abhinandan did on 27th February 2019, nobody in the world has done thus far. Okay.
Yes.
Okay, see you all.
Okay,
Good
sir.
evening.
Thank you so much, sir. Thank you.
Namaskar.
Yeah. So, participants, we'll move on to the next session. So the next session will be handled by